Good morning, everyone, and thanks for joining us. Today, we are very pleased to host a joint webinar with VMware. The topic for the webinar is VMware and Big Switch, delivering powerful and operationally simple OpenStack cloud. I am Bala Ramachandran, Director of Product Management at Big Switch, and I'll be your host for today's webinar. Joining me today are Arvind Soni, OpenStack Lead Product Manager at VMware. Welcome, Arvind.
Thank you.
Prashant Gandhi, VP Products and Strategy at Big Switch. Welcome, Prashant. Pleasure to be here. And Arkady Shapiro, Principal Technical Marketing Engineer at Big Switch. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or a recording, just go to bigswitch.com/webinars and submit a question using the link provided. We also provided you with handouts for today's session. You can download them from the handouts tab on your dashboard. On to the agenda for today's webinar. Arvind will kick us off with an overview of VMware Integrated OpenStack and its unique value proposition for VMware customers. Prashant will then take us through the details of VMware Big Cloud Fabric joint solutions, highlighting some of the key operational benefits of the solution. Finally, we'll get into Arkady's demo of the solution, followed by a Q&A. Without further ado, over to you, Arvind.
Thanks, Bala. All right, folks, good morning, or good afternoon, or good evening, wherever you are. Thanks to Big Switch for giving me an opportunity to come and co-present with them. I was thinking about what I should present here, and I thought there is a lot of confusion, a lot of questions out there in the market with respect to OpenStack. So I'll just share at a very high level some decision points, some clarity from what I have learned working in OpenStack space for about 3.5 years, almost from the time it started taking off and from scratch. So the way we define OpenStack, first of all, you gotta be able to define it, right? The way we define OpenStack is essentially a framework where you can plug in various different products, different hypervisors, different switches, different storage, and things like that. Once you plug it in, what you get is a very AWS-like set of IaaS services. So think of it as EC2 equivalent to Nova, and VPC equivalent to Neutron, and EBS equivalent to Cinder. But you need the underlying products, the hypervisor, the SDN, the SDS, and things like that, right? Because this framework is not going to work on its own. It needs the underlying products. So you get the AWS kind of services, and you can use the growing system of ecosystem of open source tools. So with that definition in mind, these are the three sort of cornerstones of OpenStack private cloud decision. Right? If you stare at various aspects of OpenStack, if you're looking to make decisions, I think these three summarize it very clearly of how you can anchor and make the decisions, right? The first of all is why build an OpenStack cloud? Why build a private cloud? Because public clouds are accessible to you. Second one is what products to choose. As I said, OpenStack is a framework. You need to choose the underlying products that you will run the OpenStack on, and this is very important decision. What you will choose depends on multiple factors, right? And then the last is what approach you want to take to build OpenStack. Do you want to do it yourself, get pull from upstream, or do you want to get some consulting services help, or do you want to take an integrated product, which is whatever VMware Integrated OpenStack is like. So let me just quickly walk through some of these decision points. So why build an OpenStack cloud? As I said earlier, it's very much, it will help you get a AWS style cloud in your backyard, essentially, right? You can run in your private data center. You can customize it. It will be your rules. You want to put SSDs. You want to put Big Switch underneath. You want to put, whatever combinations you want to put there. You will get the benefit of your customization, your rules, the way you want to use the cloud and meet the SLAs and requirements for your end users, right? In AWS, you play by AWS rules. You give them the credit card. You play by their rules, right? That's pretty much at a high level the gist of it. Now, what do you get out of OpenStack Cloud? You will hear a lot of things. I'm going to save a ton of money. I'm going to be, there will be no vendor lock-in. You got to take some of those things with a pinch of salt and dig deeper, right? Where are you saving the money? I mean, you need the products underneath, OpenStack distributions are pretty much free from all the vendors. So you're really making the decisions on what products you will use underneath, and that should be irrespective of whether you put OpenStack or not, right? You should value what those products are bringing and whether you can operate those products or not, right? Whether you trust them, whether they're proven to run your workloads. So it's not clear whether OpenStack saves anybody any money anywhere. And there are Gartner reports and 451 reports that you can search and find evidence of this, right? Avoiding vendor lock-in. This is again a sort of a unicornish proposition. You know, how often every one of you has a lot of experience running data centers. How often have you in past switched a hypervisor or switched storage? Those things are inherently very difficult, and OpenStack does not really make anything much easier, right? So really what it boils down to is you will get the AWS style services, you will get the APIs, you will get a lot of boost in developer productivity, right? The same agility that you get against AWS cloud, you can deliver it in your private cloud, right? Now this is the most important decision with respect to OpenStack. Once you've decided that you will build an OpenStack cloud, look at the amount of combinations that OpenStack offers, right? And this is great. You get a lot of choice. But the flip side of that is which one of this works? Which one of these can you make work, right? Do you have expertise to do XYZ combinations? Because when you're building a cloud, it's not just about the compute or the server part of it. You need the network and storage, everything automated, and you need to be able to operate it, right? So you got to take a hard look and make the decision, hey, on the points like which one of these I know work, right? Which one of them I can operate, and can I get support for this infrastructure combination? Yeah, you can go buy ABC combination, but who has tested this and who is going to support it, right? So these are very, very crucial because your workload ultimately will run on these products, and these products have to be reliable for you to confidently go to production and reap the benefits of OpenStack. Last decision point, how will you build OpenStack, right? It's open source. You can go DIY. You can download, you know, from GitHub, and you can put a whole bunch of engineering resources behind this, or you can go get consulting services and help you stitch everything together. But the key thing to note here is that you don't want to get into a snowflake unique cloud, right? Otherwise, you will rat hole yourself into a lot of customization, a lot of unique features that you only have in your cloud, which will cause you to drift away from upstream and cause you to lose all the benefits of going open source in the first place, right? So you want to lean more towards a standardized approach. What I mean is, you talk to the vendor, you ask them, hey, if you deploy 10 different OpenStack clouds, are they all different, or is it just one OpenStack that you deploy 10 times, right? Because if you deploy one OpenStack 10 times, you get the benefits and learnings and bug fixes from all of them, and you can accelerate faster and move faster. Whereas if each one of those deployments are different, then it's going to be very hard in the long run to sustain. So no snowflakes. I think that's the key learning here. Try to lean towards the standardized APIs, the standardized architecture, the standard set of products that will help in the long run. So enough of those decision points. That's food for thought. I think if you make right decisions along those lines, you will see a lot of success with OpenStack. You will see enormous productivity boost with OpenStack. And you can complement your existing data center or hybrid cloud efforts with OpenStack very nicely, right? So what is our approach? So we fall into the category of integrated product approach, meaning we will, we reduce your choices around customizations maybe, or we will warn you that, hey, don't go changing all these 10 things. It will destabilize or cause you to become a snowflake. So we provide a lot of the standardization, right? And we support enormous amount of various features inside it so that you don't need to tinker and tweak every little thing, right? So first of all, we run it on proven products of VMware. Naturally, those are the products that we can support. So vSphere, NSX, vSAN, all the investment that you have in VMware, you can use with OpenStack. With VIO, we have made it really easy for you to deploy and operate and patch and upgrade OpenStack. So all the headaches that you hear about OpenStack, pretty much gone in VIO, right? And then you will get all the features from VMware's products. So you love DRS, HA, vMotion, storage clustering, reservations, everything is preserved, and you will get all the benefits of vSphere as well as NSX. Complete overlay networks, distributed firewalling, NATing, the things that you need for production environment from networking perspective. Right? All of this is delivered in a standard architecture. As I said, no snowflakes, right? When we go ahead and deploy hundreds of these VIO at customers, they are all running the same standard OpenStack. So you will get the cross-fertilization and benefit from learning from all of them. So what's inside? Let's zoom in. It's essentially delivered as an OVA. It's available free. You can go download it from our product page. Just download the OVA and go to your vSphere web client and install it. It has all the core OpenStack components: orchestration, compute, network, images, everything just like the standard OpenStack. No secret sauce of any sort. In fact, we were one of the first distributions to become DevCore compliant for Kilo. We understand very much the value of the OpenStack APIs and the standardization, right? So that you can move your apps across various clouds. As I said, it comes with an installer, so it has its own deployment, configure, patching, password recycle, certificate management. There's a lot of value in the simple management server that we ship, right? So you don't have to reinvent the wheel about every day-to-day task that you have to do with OpenStack. And it also integrates with our management line of products. If you have vRealize operations, log insight, or business, you can use those to monitor and troubleshoot. So pretty much everything to get you going and go to production very fast. So what's the result, right? What's the result of this approach? I want you to focus on the time it takes for you to go to production with VIO. It takes people several weeks to months just to get a POC going. Here we have customers who are running very large deployments, running their e-commerce websites, running like a very mission-critical analytic workloads or CI/CD pipeline. And these people were able to go to production in a matter of weeks. And I'm not talking POC. This is like, critical workloads running in production within weeks starting from scratch, right? And another big headache in OpenStack is lack of OpenStack expertise. Well, you don't need any major PhD in OpenStack for VIO. All you need is your existing VMware skills. You get going, and then over the course of time, we work with you if you need any additional training, we give you that, right? So you can see all of these are pretty much run by a small number of vSphere employees, right? And as I mentioned, you get all the benefits of vSphere, all the benefits of NSX, all the investments that you have, right? And you can run pretty much any kind of workloads. It's nothing to do with pets, kettles, or any kind of pet-kettle combination that you have, container or non-container. You can run any workload that you have. This is a very general purpose IaaS cloud. Just like you can run anything on AWS, well, not necessarily, but not the pets over there, but this is actually more powerful in that regard, right? Completely supported by VMware. You don't have to run around like headless chicken chasing the storage guys, the network guys, the compute guys. 1-800 VMware for top to bottom. Nova is broken, fine. We'll take the call. We'll give you the hot.
You're not trying.
The whole call going on. So in a nutshell, you got to do the important decisions up front. How you will build OpenStack, why you will build OpenStack, what approach you're going to take. Just key things to avoid there are things like snowflakes. Use the infrastructure that you know how to operate. Use good products like Big Switch so that you get complete transparency underneath, right? Use NSX for overlay automation and providing you the network automation that you need. Use vSphere because you know it and it's reliable for production workloads. And then use VIO because it will give you enormous amount of simplicity for zero license cost, right? So over to you, Bala.
Thank you, Arvind. That was great. It was great to learn that VIO offers the most complete and operationally simple approach to OpenStack for VMware environments. So one of the key elements of the infrastructure is a physical network, and we have always heard that automation and troubleshooting that is a critical need. And that's a key problem that the VIO and Big Cloud Fabric solution addresses. So let's dive right into it. Over to you, Prashant.
All right. Perfect, Bala. Thank you. And thank you, Arvind, for that fantastic overview. Given the fact that a large number of virtualized workloads are on vSphere, the fact that customers have operational teams that are already trained in vSphere simply extend over through VIO to now enable private cloud on vSphere. So as Bala pointed out, there are really two components to this. There is a software stack from virtualization and above, where VMware's VIO solution is operating, and underneath it there is a physical fabric, physical switch infrastructure, leaf and spine infrastructure that still needs to be there. And we have seen in traditional box-by-box networking that this physical infrastructure is really very painful, very complex, very proprietary, very expensive, vendor lock-in, and once when it's deployed, to troubleshoot it becomes often a nightmare. And so what BigSwitch has done is applied the principles of hyperscale style networking, where we have seen in the compute environment, large mainframes have been disaggregated into x86 based infrastructure with software as a key piece to still build supercomputers, scale out supercomputers, very cost efficient environments, very large supercomputers, but using commodity components from hardware, and then leveraging intelligent software so that customers can make independent decisions across their purchase of compute hardware and their purchase of software on top of it. And they are able to choose a variety of hardware vendors to be able to run the same software. And so what we have been doing is really on the main, this whole approach that has happened of disaggregation of the mainframe. We want to bring that to compute, to networking. And if you look at these large proprietary chassis infrastructures, we jokingly call them mainframe of networking, or net frames. And our approach is to really disaggregate these into an architecture, a fabric architecture that leverages commodity and very standards-based switches, and one has choice of multiple switch hardware vendors. In our case, one can have branded white box switches from Dell, for example. Gartner calls them britebox switches, and Acton, which would be ODM-based white box switches. All of these based on Trident 2, latest and greatest Broadcom ASIC, and these are all going into next generation ASICs, which are Trident 2 Plus and Tomahawk. So very standardized hardware. And what BigSwitch does is really offer software on top of it. So SwitchLite operating system, as the diagram shows, that sits on each of the switches. It is fully managed by the Big Cloud Fabric controller that builds the entire leaf-spine topology. It manages the L2 and L3 forwarding paths. It is completely zero touch. Change management occurs can occur at a moment's notice. You simply rack a switch, cable it, and walk away, and it gets admitted to the fabric. It gets its configuration, and one manages everything through the Big Cloud Fabric controller, which has CLI interface, which has a GUI interface, it has API interface as well. And on top of that, then we integrate into the vSphere environment. We are able to interoperate with NSX, and now with this solution, we have shown that we can now support VIO as well, as we'll go through in detail, and then follow that up with a demonstration of how the interoperability works. Now, what's the value proposition overall with this? And I talked about the traditional box by box being very complex and very brittle, very manual, hard to troubleshoot. Our purpose here with this new style, modern style of network infrastructure, fully disaggregated and SDN-driven physical underlay, is really to focus on what we call the save principle. We'd like to save customers money, and we'd like to save customers time. And save, we really break it into the four letters, right? S for simplicity, A for automation, V for visibility, and E really, as combination of this, provides a real economic advantage from overall total cost of ownership, and the fact that one has multiple hardware vendors to choose from, that is a significant benefit for customers. And so, so with this now, how is our focus in bringing the same principle to VMware environment? And so we have really three main use cases within the VMware ecosystem of software and solutions. The first one is standard vSphere, vSphere 6. The big cloud fabric integrates with vCenter, and we enable, significant level of automation and visibility, detect ESX hosts as they connect, create networks on the fabric, monitor vMotion, provide all of that visibility to the network team. And the whole idea is that the virtualization and NSX overlay visibility now can be provided to the network team who typically would not have that visibility under normal operating environment. And so troubleshooting now becomes easier because they're able to consistently view the environment and have a more meaningful conversation with the virtualization admin, the VMware admin. The second use case is ability to now instantiate multiple such vSphere instances on the same big cloud fabric, on the same physical fabric. And this is a very unique use case. What it enables is through the big cloud fabric controller integrating with multiple vCenters simultaneously and in parallel to build what we call isolated logical pods or virtual pods. We call them vPods. So each vPod can have association with one vSphere, and you can have dozens of such vPods on the same big cloud fabric. And we can support mixed environments. So you can have a set of vPods for vSphere 6, a set of vPods for NSX overlay, a set of vPods for VIO. And this sort of highly mixed environment is fully supported with big cloud fabric. It's a very unique value proposition and provides a significant flexibility in deploying multiple vSphere-based solutions on the same physical fabric in an automated way with full visibility. And the third use case is what we are discussing here, which is the VMware VIO use case, where we are now extending this with VIO and the entire OpenStack solution that VMware is providing and supporting with big cloud fabric as the SDN underlay. So sort of leveraging Arvind's slides where he talked about VMware solution for OpenStack, the VIO, with VMware SDDC as the substrate, and then on top of that, adding the OpenStack solution, providing simplification, differentiated features, and the fully standards-based, production-ready OpenStack, ability to connect into vRealize environment. And as you can see in the diagram at the bottom, we have the SDN underlay, which is the big cloud fabric, the leaf-spine fabric driven through the BCF controller, acts as the SDN underlay for VIO and for NSX, and it has the vCenter extension built in to be able to connect and operate bring the automation to the physical underlay. The big switch BCF also has a content pack in vRealize Log Insight, so all of the logs and events can be visible directly to the VI admin through their vRealize Log Insight console. So let's look at kind of the solution with the next level of details. As Arvind pointed out, within OpenStack there is Nova and for compute, Neutron for networking, and VMware solution integrates that with vCenter and NSX Manager, NSX for Neutron networking, vCenter for compute. And with Big Cloud Fabric's integration of vCenter APIs through the vCenter extension embedded in the Big Cloud Fabric controller, we are now able to bring that interoperability, visibility, and simplification even when even for the physical fabric. So as tenants are created in VMware OpenStack environment, that's great. vCenter provides the management for host and VMs. NSX does all the L2, L3. And what the Big Cloud Fabric does with the vSphere integration is provides the fabric automation and the visibility. So let's drill down in what the automation is. So first, when ESX and NSX hosts are attached to the fabric, connected to the leaf switches, we automatically detect them and admit them into the Big Cloud Fabric controller, and we form the link aggregation between the server PNICs and the leaf switches. This is completely zero touch. You never have to configure any of the switches nor the interfaces. The controller takes care of this in a fully zero touch manner. Then creation of NSX transport network so that VTAPs can communicate and build an overlay. This is automatically created on the Big Cloud Fabric, and we learn the VMs that are behind the VTAPs. And the VTAPs themselves are auto-discovered so that when we do troubleshooting, all of that visibility is provided. And so what are the capabilities for visibility and troubleshooting? Really, VM level visibility. We'll go through the demo here. Arcade will show the analytics and how VMs are visible. Same thing, VTAP, VTAP visibility, VTAP to VTAP troubleshooting. So you can actually go from source to first off leaf to spine to the destination leaf and destination host. You can trace that entire path through the Big Cloud Fabric and between source and destination VTAPs, source and destination host, so that now VM to VM troubleshooting can become very easy. The VI admin team and the network team can very quickly resolve the issues, identify whether or not the physical infrastructure is where the issue is, and then figure out what the issues are. Additionally, we have the in the controller built-in analytics leveraging Elasticsearch, Kibana, and Logstash, the ELK stack for analytics, and we are able to leverage that to bring vSphere visibility and NSX visibility to the network admin. And Arcade will show that in his demo as well. So finally, as I mentioned, Big Cloud Fabric also integrates with Log Insight. We have a content pack for vRealize Log Insight. You can download this from VMware Marketplace for content packs, and thus it allows the VI admins to have full visibility to the physical fabric, just like the network admin has full visibility to the virtualized and overlay environments. So both teams have visibility to both environments, physical and virtual and overlay, and we believe this level of consistent view and visibility enables rapid troubleshooting when issues show up. Finally, vPods. I mentioned a very unique capability, highly differentiating for Big Cloud Fabric. Here we have shown in the diagram 3 vPods. First vPod in green is plain vanilla vSphere. The second vPod has NSX overlay running on top of it. Third vPod with a third instantiation here with VIO, and each one has isolated instances of vSphere. In the case of standard vSphere vPods, we support overlapping IP addresses, take care of VLAN configurations, and resolve any conflicts there may be. So very powerful capability that is available in the shipping release. Get started. Well, if someone wants to learn about Big Cloud Fabric with VMware solutions, so we have free online labs. If you'd like to try it in your own environment and try any of these use cases, including VIO, we have a free software with our community edition that you can download. Simply purchase a compliant switch and enable this in your own lab environment. If you'd like to take any of this to production, we have very low-cost starter kits available, starting $39K with 2 switches, 2 leaf switches, and a spine, and all the software and support to be able to get started. So with that, Bala, over to you. Thank you.
Thank you, Prashant. It's clear from your talk that BCF can be a fantastic underlay for NSX and VIO. So Arkady will take us home with this demo.
Thank you, Prashant and Arvind. Hello, everyone. My name is Arkady Shapiro, and I'm Principal Technical Marketing Engineer at Big Switch Networks. In this demonstration, I will provide an overview of VMware Integrated OpenStack deployment running on top of vSphere and NSX with Big Cloud Fabric. Along with that, we'll observe the benefits of physical fabric automation and advanced visibility into virtual environment that the solution provides. Here's the setup we'll be using today. We have a Big Cloud Fabric with 2 dual-leaf racks, 2 spines, and a pair of SDN controllers. Several ESXi hosts connect to each rack. We deploy 2 vCenters, one for classical vSphere networking corresponding to Virtual Pod 1, and another one for VMware Integrated OpenStack and NSX corresponding to Virtual Pod 2. Big Cloud Fabric is connecting to both vCenters. OpenStack and NSX Manager communicate with vCenter 2 only. As Prashant alluded to earlier, this provides a unique value to a customer who may have an existing vSphere deployment and wants to deploy VMware Integrated OpenStack without disrupting existing environment and without building a whole separate physical fabric. Here's the deployment workflow for the solution. Once Big Cloud Fabric, vCenter, NSX, and VIO are set up, we enable BCF integration with vSphere by registering BCF controller with vCenter. On NSX, we do host preparation, which creates VXLAN tunnel endpoints and NSX transport network. This network is used for all NSX VXLAN traffic going across physical fabric between VTAPs. Then we deploy VMware Integrated OpenStack on vCenter. OpenStack Nova uses vCenter driver to leverage vCenter for VM scheduling and management. Similarly, OpenStack Neutron uses NSX driver for all networking needs. Lastly, we create an external network on VIO to enable external connectivity to OpenStack tenants. The demo will highlight specific operational benefits that can only be realized when deploying and managing our joint solution. We'll talk about automatic ESXi host attachment, NSX transport network creation, VTAP to VTAP visibility, and BCF analytics for NSX. So let's first review the setup and talk about deployment benefits. Let's log into BCF Fabric and see the physical SDN fabric setup I mentioned earlier. We can see 2 controllers, several racks, and 2 spines. Clicking on any switch can show fabric links along with utilization. Let's go to Integration tab to enable VMware vCenter integration with BCF. We have already enabled it by providing several parameters such as username, password, and tenant corresponding to virtual pod and other information. Let's look at vCenter web interface. We have 2 vCenters as mentioned earlier, one corresponding to Virtual Pod 1 with classical vSphere setup, and one corresponding to Virtual Pod 2 with vSphere, NSX, and VIO. In vCenter 2, we have a compute cluster for VIO workloads, edge cluster for NSX edge routers, and management cluster for VIO and NSX infrastructure components. Now let's look at NSX configuration. As you see, all ESXi hosts and compute and edge clusters have been prepared for NSX networking. In VXLAN section, all hosts have VM kernel interfaces corresponding to VTAP endpoints on each host. On VMware Distributed Switch, NSX host preparation created port group corresponding to NSX transport network. Let's go back to Big Cloud Fabric and look at physical fabric automation. We can see the ESXi host being discovered via LODP and link aggregation groups automatically created, including all uplinks from virtual switch on ESXi. Expanding on individual link aggregation group, we can see how hosts are physically connected to switch ports and corresponding ESXi VMNIC info. It is important to note that without a zero-touch physical network solution that Big Cloud Fabric provides to complement the virtual network solution from VMware, this task would be very time-consuming and error-prone. Let's look at the second part of fabric automation. As you see in tenant configuration, Big Cloud Fabric auto-creates segments for all VMware virtual switch port groups. Here we have NSX transport network and external network. Big Cloud Fabric also auto-provisions and prunes segment membership based on presence of VM or VM kernel interfaces. In endpoints under the segment, we can see VM kernel interfaces that correspond to VTAPs. BigCloud Fabric provides valuable information about additional endpoints that are behind VTAP and therefore do not directly connect to the fabric. Similar information can be seen in vCenter Integration tab under Specific vCenter, except here it is focused on just the virtual machine endpoints under that specific vCenter. We have looked at host, segment, and endpoint information from perspective of vCenter and BigCloud Fabric. If we go back to vCenter and go to the BigCloud Fabric vCenter plugin view, you can see much of this information merged together in a single pane of glass. For example, looking at virtual distributed switch on specific host, we can see corresponding port groups, including VM kernel and those behind the VTAP, as well as physical uplinks. In segment view for NSX transport network, we can see that fabric membership in NSX transport network was provisioned for these hosts. Now, let's take a look at OpenStack setup and tenant multi-tier application deployment. We have deployed OpenStack in vCenter management cluster with controllers, load balancers, and other infrastructure virtual machines. If we log into OpenStack Horizon dashboard using a pre-created project credentials, we can see that we have deployed a tenant, networks, and routers. We have added 2 virtual machines in each network. Going back to vCenter, we can see NSX deployed logical switches corresponding to each network. Each one is mapped to a specific VXLAN virtual network identifier, or VNI. Let's look at the virtual machines that are deployed. We can see virtual machines app1 and app2 from network app, and virtual machines web1 and web2 from network web. From BigCloud Fabric, there is no configuration change for these virtual machines, since the network acts as a physical underlay for NSX overlay. Let's log in to virtual machine app1 and ping virtual machine app2 in the same segment. Now let's ping virtual machine web2 in another segment. We have now deployed application using OpenStack with vCenter, NSX, and BigCloud Fabric handling workload traffic. Finally, let's look at how BigCloud Fabric brings extra visibility to VMware Integrated OpenStack and NSX deployment with test path and analytics. Starting with test path, we can trace a path between VTAPs. Earlier, we noted VM kernel endpoints corresponding to VTAPs on ESXi servers. We can pick endpoint corresponding to VTAP on server 9 as a source and VTAP on server 8 as a destination. Simulate option provides a controller view of whether communication should occur. A test mode provides an interface level details and actual path that was taken by VTAP to VTAP traffic across the BigCloud Fabric. Now let's look at BigCloud Fabric Analytics, which is there to give details on Fabric, vCenter, and NSX events. First, let's look at all VMware events, where we can see information on all vCenters, hypervisors, and virtual machines. Here we also have ability to drill down on any one of them for more specific event information. Next, we'll focus on NSX dashboard, where we can see information on VXLAN virtual networks and associated virtual machines. For each VM, we can view events which, along with the type of event, will show useful information like logical switch name, VXLAN virtual network identifier corresponding to NSX logical switch, and virtual machine name. In summary, BigCloud Fabric leverages vCenter integration to provide physical fabric automation and visibility for VIO deployment, which uses vCenter and NSX for VM provisioning and networking respectively. Like Arvind and Prashant mentioned, the solution is very simple and one can get up and running with their private cloud in no time. This concludes the demonstration, and I'll turn this back to you, Bala.
Thank you, Arkady. That was great. And thank you, Arvind and Prashant, for your great presentations. Let's get into a quick round of Q&A here. There have been a few interesting questions, and first one for you, Arvind, a very fundamental question. Why are customers running OpenStack on vSphere?
OpenStack on vSphere. Yeah, that's an excellent question, and I saw some of those questions on the question board over here as well. Well, first of all, as I mentioned, OpenStack itself is a framework. I mean, that has to be absolutely clearly understood. So you will need something underneath. Whether you run bare metal, whether you run XYZ hypervisor, it doesn't matter. You will need something, right? So vSphere is one of the most powerful virtualization platform, not just ESX part of it, because it not just provides you the virtual machines, but provides you with a lot of capabilities such as DRS, You can enforce affinity, anti-affinity reservations, things like that. You can do maintenance seamlessly on the server without any downtime to the workloads, for example, right? So vSphere is a complete platform that provides you tremendous virtualization benefits, right? And all of these are either important to the operators or to the consumers. And biggest thing of it is that most of the people know how to run these environments. Now, as I said, you can put A, B, C things underneath OpenStack. The question you need to ask yourself is, are those A, B, C combinations reliable? Do I know how to operate them? And from our customer base, from where we look at it, yes, vSphere is very reliable. Our customers know how to run vSphere, and OpenStack to them is a way to consume the infrastructure. So why run OpenStack and vSphere? It's best of both the worlds. OpenStack brings you AWS-like APIs and services. vSphere brings you one of the best hypervisor platforms ever, right?
Yeah, it's something they can try in a very familiar environment.
Yeah, and VIO will help you get there rapidly fast. Right?
Yep, great. So I have a question for you, Prashant. It's a two-part question. So what kind of interfaces are available for BigCloud Fabric today? So CLI, GUI. And the other question is how is BigCloud Fabric differentiated versus traditional competitive vendors?
Yeah, so first, in terms of the interfaces, we should also talk about physical interfaces. So it supports 10 gig and 40 gig environment. So you can have 10 gig to the leaf, 40 gig to the leaf, and then 40 gig to the spine. So very modern, high performance fabric can be built with these switches. In terms of the interfaces on the controller, the controller comes with, it is not only the control plane, but it is also the management plane and the policy plane. And so it has a CLI environment, so one does not have to, very familiar industry style CLIs are supported, so network admins can feel very comfortable with that. But we have found that our GUI, very modern Web 2.0 style GUI, is where many of the folks who traditionally had done CLI are very, very attracted to, and they've made the GUI as their main tool for all of the configuration and visibility and management of the BigCloud Fabric. So very, very exciting to see that in the networking world, we are finally seeing customers and the administrators choosing GUI because of the workflow benefits that it provides. Versus the traditional way of taking CLI and converting into GUI, buttons was not the right way to support GUIs. And finally, API. Everything that we do has APIs, and we leverage those APIs to even for our GUI and CLI. GUI and CLI are clients of the API, so we have this API first principle. And therefore, and additionally, for every GUI workflow or CLI, you can actually print the APIs, the REST calls. So one does not have to do any guesswork. You can simply take your CLI workflow or GUI workflow, print the equivalent REST calls, copy them, put them in your scripting environment, your Python scripts, and bring that automation, your custom automation. So very, very easy to bring this level of automation in the Cloud Fabric.
Great. There's another interesting question about the multiple logical pods, which you talked about, which are supported by BCF. Do you have an example of a real-life deployment of this?
Yeah, absolutely. We have a cloud provider who is providing managed vSphere based multi-tenant private cloud to enterprise customers, and it's U2 Cloud. We have a public case study of this. They have deployed over a dozen, vSphere instances on a single BCF substrate, the physical fabric, and each tenant can have their own isolated vSphere, and the BigCloud Fabric provides full automation and resolves all of the network and conflicts. The newest use cases we are seeing is with now leveraging vPod concept to not just support vSphere, but also NSX for vSphere, VIO for vSphere, that we can bring multiple such heterogeneous components and solutions on the same underlay substrate. Not only managed cloud providers can offer these variety of services and value-added services, with the same substrate. But in addition, even in dev and test environment where one is, building this, want to have a low-cost physical infrastructure to support and test multiple such variations and solutions, they can deploy that in engineering labs and dev and QA environments.
Great. So you're really catering to multiple audience here, the cloud admins, the network admins, and so on.
Absolutely.
Yeah. All right. Thanks for that. And we will get back to you with responses for some of the other questions. And Prashant talked about getting started with the BSN Labs Community Edition and Starter Kits. So do give them a try, and let us know if you have questions about that at info@bigswitch.com. All of our past webinars, including this one, will be posted online. Our next webinar will be on March 9th. Mark your calendars for a deep dive webinar to learn more about Big Cloud Fabric 3.5. Watch your emails for registration details, or visit our website at bigswitch.com/webinars. That concludes our presentation for today. But if something we discussed here piqued your interest or you'd like to know more, just head on over to our website, bigswitch.com. Thank you and have a great rest of the day.